GEM Developers presents Synergy in Science Education. Diamonds. This simulation can be used to explore the physics of diamonds. Some of the topics we'll be investigating today include the refraction of light, measuring angles and the critical angle, and how the critical angle is involved with diamonds. We'll be looking at cut and different types of cut, including excellent, good, and poor cut. Color, clarity, and carat weight will also be explained. And finally, we'll be looking at diamonds and fire. Let's begin. Light can sometimes pass through a substance that it is incident on. For this example, let's assume the source of light is located inside the glass. So usually we call this beam of light the incident ray. Now two things happen to the incident ray. It's reflected, and we say this light that escapes from the glass is refracted. Notice it changes directions. Let's move the light source around the glass and see what happens. Notice when the light hits head-on, it travels straight through and does not refract or change directions. Notice at this point that all the light is 100% reflected. If we increase this angle, it's still 100% reflected. This glass surface acts like a mirror. When all the light is 100% reflected, we call this total internal reflection. This is an important concept for you to understand in regards to diamonds. Now in physics, an imaginary line, the dashed line here, called normal is used to measure angles. Notice that the angle of incidence is the same as the angle of reflection. The critical angle is the smallest angle of incidence for which the refracted ray disappears and the light does not escape. Now for this example, that angle is approximately 46 degrees. Notice at 46 degrees, the light no longer exits or escapes from the glass. If we increase that angle, well, notice it still doesn't escape. For diamonds, the critical angle is much smaller. It's about 24.4 degrees. This results in total internal reflection occurring several times, giving the diamond its sparkle. Now, a high-quality diamond reflects most of the light, striking it back upwards towards the observers. The more light it reflects, the brighter the diamond appears. A low-quality diamond does not reflect the light and appears dimmer. So here we have two light sources on two diamonds. Let's take a look and see what happens. So in the first case, the high-quality diamond, notice the light is reflected upwards. This is where a person would be looking at it. In this case, however, notice the light does not reflect upwards. It escapes. It's lost. Let's now try to understand the four C's of diamonds. To begin with, cut. The quality of a diamond depends on the cut, clarity, color, and carat. The cut of a diamond includes the amount of light reflected back towards the observer. Three main factors to consider: size of the table relative to the diameter. This is called the table size percentage, the crown angle, and the pavilion angle. Now the cut shown in figure 1 has excellent proportions. Figure 2 illustrates how a diamond would appear from an overhead perspective. For an excellent cut, this is how light behaves when it enters through the table. Notice that total internal reflection occurs two times, at this point and at this point. When light strikes the facet, it escapes. Now, total internal reflection occurs because these angles are greater than 24.4 degrees, the critical angle for diamond. However, here, at this point, it's less than 24.4 degrees this angle, therefore the light is able to escape and return back to the viewer or the observer. This is how light behaves when it travels through the facet. So it enters at this point, and again, total internal reflection occurs 2 times, at this point and at this point. Once again, this occurs because these angles are greater than 24.4 degrees, the critical angle for diamond. Here the angle is only 4 degrees, therefore the light is able to exit. Let's take a look at that one more time. Now for an excellent cut, let's view how light enters from many different positions. So notice that all the light that enters through the facet is reflected upwards. Notice also that most of the light reflecting through the table is also reflected upwards. Except at this point, the angle changes somewhat. And so these are the key characteristics for an excellent cut. Light is reflected upwards as it enters through the facet. It's again reflected upwards as it enters through the table. And most of the light is reflected in the same direction. Now there are several different combinations of pavilion angle, crown angle, and table size percentage that produce an excellent cut. Let's take a look for this particular diamond. Once again, these proportions have changed, and yet they produce the same type of effect, where light is reflected upwards as it enters through the facet. And again, as it enters through the table, light is once again reflected upwards. So there's a range of values that produce excellent cuts. Now let's take a look at a good cut.